Our world runs on microchips. They are the invisible engines driving our smartphones, cars, and even washing machines. These tiny pieces of technology, smaller than a fingernail, hold immense power and complexity. Imagine a city bustling with activity all packed onto a surface smaller than a coin. That's essentially what a microchip is, a miniaturized city of electronic components working together. These chips are the unsung heroes of the digital age, silently orchestrating the flow of information and enabling the technologies we often take for granted. Microchips, also known as integrated circuits, are made primarily from silicon. Silicon, a readily available element found in sand, possesses unique properties that make it ideal for controlling electrical current. Think of silicon as a blank canvas. Using complex processes, we carve billions of tiny transistors onto this canvas, creating pathways for electricity to flow. These transistors act like miniature gates, switching on and off billions of times per second to process and store information. The more transistors we can fit on a chip, the more powerful it becomes. Creating a microchip is like building a microscopic city. It requires meticulous precision and involves numerous intricate steps. First, silicon is purified and sliced into thin wafers. Then, using a process called photolithography, intricate circuit patterns are etched onto the wafers. Next, layers of different materials are deposited and etched away, creating the transistors, resistors, and capacitors that make up the chip's circuitry. Finally, the wafer is cut into individual chips, each a marvel of miniaturization and engineering. Microchips come in many forms, each tailored for a specific task. Logic chips, like the CPU in your computer, perform calculations and make decisions. Memory chips store information, while specialized chips control everything from your car's engine to your smartwatch's sensors. As technology advances, microchips continue to shrink in size and grow in power. This constant miniaturization allows us to pack more functionality into smaller devices, leading to faster phones, more powerful computers, and even implantable medical devices. The future of technology hinges on our ability to continue innovating in the world of microchips. As we push the boundaries of miniaturization and explore new materials, we can expect even more groundbreaking technologies to emerge, powered by these tiny giants. The journey of microchips began in the mid-20th century. The first integrated circuit was created by Jack Kilby in 1958 at Texas Instruments. This invention revolutionized the electronics industry. Over the decades, microchips have evolved, becoming more powerful and compact. From simple circuits to today's complex processors, microchips are the backbone of modern technology. Microchips profoundly impact our daily lives. They power our smartphones, medical devices, cars, and smart homes. Microchips revolutionize education, entertainment, and industries. They are the silent workhorses of modern civilization. The potential for microchips to revolutionize our world is boundless. Future Innovations Gap 3S. The future of microchip technology is incredibly exciting. Researchers are exploring new materials such as graphene, which could lead to even faster and more efficient chips. Quantum computing, which relies on quantum bits or qubits, promises to revolutionize computing by solving complex problems that are currently impossible for classical computers. Additionally, advancements in artificial intelligence and machine learning are driving the development of specialized chips designed to accelerate these technologies. The possibilities are endless as we continue to push the boundaries of what microchips can achieve.